Welcome to Homework Lib.
Okay, so here red light of wavelength lambda, let me write that here, red light of wavelength lambda r is equal to 700 nanometers is passed through a two-slit apparatus. Now at the same time another monochromatic light is passed. Let us consider that to be lambda, the wavelength of light. Now it was seen that the center of the third bright fringe appears pure red. So that means that that position, at that particular position, the red light, the lambda r, went on to have constructive interference, whereas lambda went on to have destructive interference. Let me write that here. At that particular point where it was red, lambda r underwent constructive interference, whereas lambda underwent destructive interference. That's why we can see pure red, right? So for that position, if that we consider that to be y, then y should be equal to 3 times lambda r d by d, where capital D is the distance between, let me write it here, so distance between slit and screen, whereas small d is the slit spacing, right? So this is for the red light, and at the same point y there is destructive interference due to lambda. So for destructive interference we write m equal to half m plus half of lambda d by d. Alright, so from these two equations, what we can figure out is that from these two equations we can write m plus half of lambda should be equal to 3 times lambda for red, right? So lambda equals to 3 upon m plus half of lambda r, right? So let us turn by turn put the values for m equal to 0 gives lambda equals to 4200 nanometers. Well, this is not in visible region, we need wavelengths in visible region, so let's move on. For m equal to 1, lambda becomes 1400 nanometers. Okay, it is decreasing, right? Good. For m equal to 2, lambda equals to 840 nanometers. Excellent, it's decreasing. Now it may reach the visible region. 3, lambda comes out to be 600. Bingo. So we have reached visible region, and this is one wavelength. Similarly, for m equal to 4, lambda equals to 466.66. Well, this also lies in visual region, right? So let us move on. For n equal to 5, lambda equals to 381.821. Okay, it has now went out of visible region. So these are the two possible wavelengths of the second light, right? Now, do you need to know the slit spacing? Well, did we use anywhere the value of d? No. D gets cancelled out when we solve these two equations, right? So let me write that here. No, we don't need it, and d gets dropped off, right? As it is same for both wavelengths. And hence this is the solution for this question. Thank you for watching.